Okay, so now we want to come up with some conditions where we know we must have an absolute max or min, a global max or min. And this is to set us up for understanding the extreme value theorem. So what I want you to do is, in these four boxes, is to draw a function that satisfies what's given. So in box 1, can we draw a continuous function? So a function where you're not picking no holes or anything like that, no jumps, no asymptotes. A continuous function whose domain is all real numbers, and that function does not have an absolute max or min. Right? So pause it and give that a try. Okay, so I'm assuming that you've given that a try. There's a bunch of things that you could have come up with. Maybe you just came up with a line. There's no biggest y value or smallest y value there, and the function is continuous on all real numbers. Or maybe you gave some sort of polynomial. I don't know, like a cubic. No absolute max or min there, and the function is continuous on all real numbers. Or maybe, I don't know, maybe you did something like inverse tangent, where you've got horizontal asymptotes at pi halves and minus pi halves. Again, that's supposed to go right through the origin. There we go. Again, no biggest y value, no smallest y value. Okay, so it's possible. Now I want us to try to draw a continuous function on the domain -2 to 2, right? That means I said -2 to 2. What does this say? It says 2 to 6. 2 is less than x, which is less than 6, right? On that domain. That does not have an absolute extremis. So that means no absolute max or min, no absolute or global max or min. Give it a pause and give it a try. Okay, so I'm assuming you've given a few things a try. We're going to have 2 and 6 on there. The function's domain is only x values that are strictly between 2. Boom. Strictly between 2 and 6, right? So not including the endpoints. So I can't send 2 somewhere and I can't send 6 somewhere. Maybe you did something like this. This function is continuous on its domain for x values between 2 and 6, strictly between them. I never picked up my pencil. And there's no biggest y value or smallest y value because of those open circles. Or maybe you put in some asymptotes. At 2 and 6. Or a combination of these two drawings. You know, there's lots of things you could have come up with. But that function doesn't have a biggest y value or a smallest y value, and it is continuous on its domain. Again, the domain right there being 2 to 6. Right? So now we're going to try to draw a function that is not continuous. Not continuous. So we are going to pick up our pencil in some way. And its domain is this closed interval. 2 is less than or equal to x, which is less than or equal to 6, right? That's the domain right there. And still, the function does not have a absolute max or min, does not have any global extrema. Give it a pause, give it a try. Okay, so again, lots of possibilities here. Maybe you had a picture like this. Now, this function is continuous on 2 to 6, but not including those endpoints, and it's supposed to. So I got to send 2 somewhere, and I have to send 6 somewhere. I don't want to send 2 to a place like this, because then I would have an absolute smallest y value. But if I sent 2 up here, we don't have a smallest y value, because this open circle is the first time that you see Mark on the page. Similarly, I got to send 6 somewhere. I don't want to send 6 up here, because then I'd have an absolute max. You know, I don't want to send 6 down here. I'd have an absolute min, but something like that would work. Your domain is including the endpoints. So maybe you came up with something like that, or maybe you still used an open circle and then a filled in circle like that, so I don't have a absolute min, and sent the y values off to infinity. Although, oh yeah, good. With the asymptote, now the function isn't sending 6 somewhere, but you could just, this would be a piecewise defined function, you could just send 6 to some point like that. That would work. Or maybe, let's do one more for fun. Maybe you were thinking kind of like this example here, where you were like, hey, it looks like a hill, but then I'm gonna make it not an absolute max. Maybe you did something like this. Okay, and I'm gonna send, I have to be continuous on the entire domain 2 to 6, and right now it's, or sorry, I said continuous, not continuous, but the function needs to have the domain 2 to 6. I apologize if I used the word continuous earlier. I might have. All these functions that I've drawn right here are not continuous. But since the domain is 2 to 6, I gotta send all x values between 2 and 6 somewhere. I don't want to send this x value to a y value above this whole graph, because then I'd have an absolute max. Similarly, I don't want to send it to some y value below everything. But if I just did something like that, similarly over here, something like that, I'd be in good shape. There's not a biggest y value, there's not a smallest, absolute smallest y value. The function's domain is a closed interval, and it's not continuous. Okay, so now lastly, that we've pushed the envelope with all these 3 cases, I want you to try to draw a continuous function, so no picking up your pencil. The domain is still this closed interval. Pick up some color. Bloop. Right again, that's 2 less than or equal to x, less than or equal to 6. And when my function has both of these features, it's continuous and its domain is closed, right? So these 2 up here were continuous on their domains, but their domains were open intervals. Here, the entire real number line, and here, the domain being 2 to 6. So if my function is continuous and the domain is closed, what must be the case? Is it possible for you to draw a function that doesn't have a max, absolute max or min? Give it a pause, give it a try. Okay. So, assuming you've been given this a try, what you may have observed is that when my domain is closed and my function is continuous, you are guaranteed to have an absolute max and an absolute min. You're guaranteed to have global extrema. And that's because if my domain is closed, my range will be closed as well for a continuous function. Right, so maybe you drew something like this. Oops, let's go to 6. Boop. Or maybe you drew something like this. You know, a lot of things that you could have drawn. You are guaranteed to have a biggest y value, global max, you're also guaranteed to have a smallest y value, global min. And those global maxes and mins could occur at endpoints, like in this picture. Or right there, we got at an endpoint, but it also could happen in the interval, right? So notice here the range of this function is also closed. So if a function is continuous on the closed interval, in this case 2 to 6, there must be a global max and a global min. When you take a topology class, you will learn about a continuous image of a compact set also being compact, right? If this domain is closed, the range will be closed too for continuous functions. And that right here is called the extreme value theorem. We're going to get extreme function values. Biggest, the absolute biggest, and the absolute smallest. All right, so now let's go ahead and read this formally and draw a couple pictures. Right. So my extreme value theorem, EVT, says that if a function is continuous on a closed interval, then that function is going to attain its absolute max y value and its absolute min y value for some x values in that closed interval, right? And again, this is true because for continuous functions, if that domain is closed, that range is going to be closed as well. Let's draw a couple pictures. Maybe here's A, B, A, B. Continuous function on AB. That went a little high. There is an absolute, a global max and that global max, this is C, global max is f of c, and c occurred in the domain in between a and b. Here's my absolute min, my global min, f of, say, it's a y value, it's a function value. And here d is a, right? And that's perfectly fine. Your absolute maxes can occur at endpoints, or they can occur in the interval. This occurred at that endpoint of x equals a. I drew it that way on purpose. It doesn't have to be in the interval. And they also don't have to be unique, right? You can hit these maxes and mins multiple times. So maybe we did something like this. Right, so here we're hitting an absolute max y value, say for this C1 and C2, again, occurs between, these are just numbers, we're being more general.